For you today, prompt 4. It says that the measures of two sides of the triangles are given. Well, clearly, you can see that they are given, even though it's not in the format that you like to see, like regular numbers. They're not. They're both considered to be what, guys? What kind of polynomial is that for the size? I know it's a triangle, but I'm talking about...
Binomial.
No. Look at the size. What do you classify that as?
Binomial.
It's a binomial, right. It's a binomial, and that's a binomial, isn't it?
Yeah.
What about the perimeter? What do we call this?
Trinomial.
It's a trinomial. What degree is that trinomial?
2.
It's 2.
Good. It's second degree. Second degree because the highest, as you can see, is a 2, right? All right. It says if P is the perimeter, which we now know, find the measures of the third side. Third side. In this case, if we label and just kind of say this, oh, so this is side number 1, this is side number 2, then this would be our third side. Is that correct? And that's something that's missing. We want to figure out what that is. I want you to start thinking a little bit here. For the perimeter of a triangle, how do you find the perimeter of a triangle? You add up all the sides. In this case, 3 sides, right? So you can clearly see that the structure of a triangle is, to find the perimeter of a triangle, you add up all 3 sides. Side 1 plus side 2 plus side 3. Why is it so important for me to write something like that down? Because at least I know that there's a format I have to follow. I don't want to break out of that format. And another strategy here, in helping you solve this kind of problem, is give yourself a smaller, simpler problem. Something that you can actually recognize and something that you say, whoa, I can do that. For example, if I were you, I'm just going to draw myself a similar triangle like that. I'll say, okay, let's assume now, if the perimeter here is given in this form, I'll give myself another perimeter, like 12. See, easy to recognize, right? And now, if the first side is given as 4x squared minus 3, I don't like that. How about I give myself a 6? Second side, let's give that a 3. Right? So that means the third side is missing. Is that true? So very similar case, isn't it? But the difference here is you can actually recognize this and say, wait, I know how to find the third side. What's the strategy here? How do I find the third side? Well, what is it again? You add what? Which is side 1 and side 2, right? So you're saying your strategy is, I'm going to go and add side 1 and side 2. Now what? Okay, so how do you find the missing side, knowing that the perimeter is 12? Yes, Isaiah.
So you add side 1 and side 2,
Okay.
and then you put it over.
Yeah, go ahead and finish it up.
Okay, you add side 1 and side 2.
I did.
And then you subtract it from the perimeter.
Subtract it from the perimeter, you said. So when you say subtract it from the perimeter, so that means the perimeter right here subtract? Is that correctly written?
Yes. No.
No.
No, why? What happened?
You have to write it out.
No, I'm just setting up a format right now. Is this correct, the way I wrote it
No,
up
it
here?
has to be the other way.
So what's wrong with this one? Perimeter minus side 1 plus side 2. What's wrong with that? Oh, well, what is it? Is this correct?
No, it's
Perimeter minus side 1 plus side 2. What should happen though? Yes. Oh, so you should have side 1 plus side 2 first before you subtract, right? So how do you force on something like that? Thank you. This is how you force it. Parentheses will force you to do this first before you subtract it from the perimeter, right? So please, for this lessons, use a lot of parentheses because that's how you force something to do first. Okay? So clearly, we know that when we do something like this, we'll get back side 3. Is that true?
Yes.
We have a structure. And we can certainly test it too. Look, 6 plus 3 is 9. Subtract it from 12. That's 3 left, right? So 3 plus 3 plus 6, that's 12. So we know that that is correct. This is the right approach. Oh, why did I write S to the third column? Should be just side 3. Okay, there it is. We have a structure. Now we can take that same structure and apply it to our real problem right there. Any questions so far?
No.
All right, so watch what happened. Here's our structure. I'm going to go ahead and close that again and plug in what we have. Do we have the perimeter? Yes, we do. So I'm just going to go ahead and write that out. The perimeter is 10x squared minus 5x plus 16, right? What do we do to that perimeter? Okay, so I'm going to go ahead and say minus. minus, parentheses, important. See, we have our structure, so we have to use that same structure. What's inside here? 4x squared minus 3. So that's side 1. What else? Plus 10x plus 7. I need to make it a bit bigger here. Plus 7. And will that give us side 3?
Yes.
Indeed. There we go. We have a structure, right? So now we have to kind of clean it up, don't we? Well, let's start from the. Let's start with the parentheses right there. When we see something like this, what should you do? Oh, so you want to combine like terms first from the inside? That's fine. That's something you can do, or we can do it later. Either way is fine, by the way. But Isaiah, do you have any suggestions? Okay. Distribute, you said. Distribute what? If there's no number out here, usually when we distribute, you should say, oh, 5 times something, right? If there's no number here, right here, how do we distribute that? Ah, it's a 1. So you don't see it? It is a 1. Okay, so this is something you need to remember. You don't see it, it's there, but you have to kind of fill in yourself. So now it's not just a negative, it's a negative 1. So let's start distributing. If we distribute, what do we have? Negative 4x squared, you said.
Plus 3.
Plus 3
Minus 10.
minus 10x
Plus
plus or minus?
minus.
Minus 7. So we got rid of the parentheses. We now have a bunch of terms, and they're a mess. We want to, what we call here, and what we want to do today is learn to combine like terms. I kind of introduced that to you yesterday already, right? So we're going to go into that today at a deeper level before we come back to this problem again, okay? So today, guys, before we get down to the final answer of this, I want to go ahead and introduce you how to combine like terms. Or I should say combining polynomials. Okay, how do we combine polynomials in this case? First of all, when we combine polynomials, we need to focus on like terms. Now, how do we recognize something as like terms? What are some characteristics that we need to look at? Yes?
They have to have the same variable, and if they have an exponent, the exponent also has to be the same.
Aha, so same variables, same exponents. And don't forget, sometimes for a term, you can have multiple variables in the term. Is that true? Like, for example, I can certainly have something like this. Multiple variables in a term. But this right here is the characteristic of that term. What is this 7 all about? It's a 7 of x squared y to the third. So for you to look for another like term, you must have the same variables and same power. So tell me if this is considered to be like term. Watch this. Yes or no? Oh, okay, so this is no. What about this one? Yes or no? Okay, so this is a yes. What about this one? Yes or no? Okay, so I heard no, I heard yes.
Yes.
Maybe.
Maybe.
Fish.
Well, let's think about this for a moment. Anyway, let me see. Okay, here we go. Yes or no? Look carefully.
Yes.
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 Why yes?
The x and y just flipped.
Yes.
Switched.
Even though they're not in the right order, but does it matter?
No.
Didn't we learn that 5 times 4 is the same thing as 4 times 5? X times y is the same thing as y times x? So multiplications are commutative, and therefore we don't care about the order. We just care about variables and power. As long as they look exactly the same, we're all good. We don't analyze as a whole. We analyze as individual. As long as they have, as long as they're match exactly, we're all good to go. So these are considered to be like terms. Okay. Any questions so far on how to recognize like terms? We're good, right? Okay. So please, next time you see something like this, it's okay for you to say that they are like term, or you don't feel comfortable seeing it like that. Just rewrite it so it looks exactly the same. Just so that you can feel confident about what you're doing. Okay? All right, so moving on here. So now we know what like terms are. Let's take a look at a sample problem. So imagine I have this polynomial right here. How do I simplify this? Oh, distribute, just like always. So we see something like this that we recognize, hey, I can certainly distribute. Let's do that. What will this get you?
Negative 14 x squared.
Okay.
Plus negative 16.
Plus,
Minus
be careful, okay? Always repeat that same thing. It's negative 2 times 8, minus 16. Next, plus 30x squared, minus 12. So here's another strategy I'm going to give you right now. Remember, we already showed you this yesterday, but it's important. That it's okay to start drawing box shapes, just so that you can see which shape goes together with which shape, okay? So if I see square term, if I determine this, that, every time I see square term, I'm going to circle. Here's a trick. When you circle, don't forget to circle the sign in front of your term as well. Gotta go with it. Cannot leave it out at all. Okay? And then the negative 16 and 12, they're both numbers, so I'm going to go ahead and use a box for that. And now at least you see it. Oh yeah, circle goes with circle, box goes with box. And when you say combining terms, just read it as is. Negative 14x squared. What is that? Plus 30x squared. Negative 14x squared plus 30x squared. What is that going to give you? 16x squared. Okay, done. Negative 16? Negative 16 minus 12, which is negative 28. Now, for those of you who are still weak at integers combining, always remember, when you have the same sign, think of yourself having the same groups, sort of. You just put them together in that same group. So if they're both negative, this negative group's going to grow bigger. By how much? Well, by how many? There it is. You have 16 over here and 12 over here combined to get 28, and they're still negative. But if you have like opposite, meaning if this is a positive and this is a negative, they don't combine. They fight off each other, okay? And whoever has the most will be the winner. Okay, for example, this is a positive 16, and this is a negative 12. The winner clearly is the 16, right? Has more. By how many more?
4.
By 4 more of the 16 group in there. That's how we determine it. Okay, so I don't want you to be afraid. A lot of what we do here is about integers, combining. So just make sure you remember that. Questions so far in the first problem? Easy enough? Okay. Check this next one out. So if I gave you the following, notice I can certainly use a lot of parentheses here just to ease the process. Okay, how do I combine this?
You distribute.
Just like always, distribute.
1.
And
And
there's a
negative
thing right here,
-1.
negative 1. Okay, so what is that going to become?
negative 7 squared.
Uh-huh.
Plus 5x minus 2.
Minus 2, good. And I just kind of bring this down, isn't it? Alright. Anything like terms? The x squared, so I'm going to go ahead and box that, let's say. Anything else? The x, so let's circle that. These are like separate groups, right? So I just want to make sure you have, you distinguish them. Yes, anything else?
Triangle.
A triangle for that one, sure. Oh look, we have all the nice shapes. Let's combine them.
Yay, 3rd grade.
What is it now?
Third grade.
2? Negative 7.
No way.
What's that going to become? Negative 5x what?
Squared.
Square. Done. Next? 8x. So if you it's a positive, of course, you want to put that. Anything else?
Minus 7.
Minus 7. And this is called a
Trinomial.
trinomial. Questions on that? So combining is not that bad, right? Okay. All right. One last round before we go back to our previous one.
That was pretty quick.
I know, right? Oh, sorry. Go ahead. Good thing's still there. Oh, I have one more problem before we go back to the problem. Just one more example. Okay. All right, we're good. Done. Done.
Last one. Okay.
All right. Okay, what do you do here?
Distribute.
We distribute.
Do we need to?
No.
No.
Why?
Because
Why is it that we don't need to distribute this sign this time? Yes, it's a positive. Because you know that positive won't change anything, is it? Notice that if this is a negative, yes, we do need to distribute negative into each. But if this is a positive, there's no point, because a positive times a positive is still a positive. It doesn't change anything. Or a positive times a negative is still negative, okay? So we don't have to. Literally, we just have to start combining. Take a look. Anything alike that you see?
X.
yeah.
X squared y. So let's go ahead and box that. Anything else? Just 2 and -5. What about this x to the third? Is there anything that we can do? Or the 3x squared? Okay. If you cannot combine them, just leave them alone. Okay. So let's write that. Let's combine first. What is this going to become? The two boxes. Very good. This is -7. That's a positive 6, which is a -1. So I can just write a -1 x squared y. Next. That. Or I can just write this first. Why am I writing this first? I want the constant to be the last. It's kind of normal. You know, not as strong to write it in different place, but I want to have it last, the constant. Okay? Any questions so far?
Polynomial 4.
Yes. Very good. All right. Now you have a good understanding of how to combine polynomials. Let's go back to this one and help me combine this. Anything that you see as like terms?
Yeah, x squared.
Oh, x squared. So I'm going to go and circle that.
And
Notice
x-
once again, I keep on reminding you, but when I circle the sign in front of the term as well. Don't leave it out. Anything else? That's
X.
the x. So let's box that. Box that. See it? Sign in front. I need to conclude. Anything else?
3, 16.
Okay, the 16, positive 16, positive 3, -7. We're good?
Yep.
All right, let's put all the circles together first. What's that going to come? 6x squared, right? Next. So cross them out. One more down. -15x. Very good. Done. What else?
Plus 12.
Plus 9.
9.
No.
9 and 12.
12. Negative
16 plus 3.
12.
Let's look at all the triangles that we have. 3 of them. 3 of them.
12.
that's 9.
12.
16 plus 3, 19.
19 by 7?
12.
12.
Oh, 9.
So, what is this that we just found?
Polynomial.
I know it's a triangle. What is
Side
it?
3.
That's side 3. Yes. That's all I would do.
Side 3.
Okay? Use the same strategy, please, when you work in your quiz today. Okay? You need to have an established structure and then find the missing side. Yes? Yeah. You can just use whatever you need. Okay? I'm just trying to get you to come up with your own and set up your own structure. Okay? All right. Here's your quiz for today.